Okay, everybody is open to page
79.
79, apparently.
It's 19.
Somebody has stolen my remote. Who is the remote thief? Thank you, Blake. It's just like my house. Hey, you know how we'll solve this argument? There you go. Then we can stop acting like an angry Muppet. It's okay. I enjoy it to a certain extent. But Sam?
But this is from our
the general hysteria. You start out, it's awesome, it's hilarious. But it's like, Sam, chill out, man. Again, it is nothing personal. By any stretch of anybody's imagination.
Sam and I are a bad combination because we get really hyped and often end up. Wait, closest episode. So does that mean we're a good combination?
Why? Actually.
Temporarily distanced.
All right. Everything in the first section is worth 2 marks each because you had to do 2 things. You had to draw an angle and you had to state the reference angle. When I say sketch, do I expect you to have brought out a protractor? No. What am I looking for? The right quadrant. Okay?
Perfect.
All right. Yeah, I heard what was going on over there.
Whoops.
All right.
Sam, you're in.
No, I don't think he was. Although a lot of parents, including my parents, introduce their children as oops or accidents, which, when you think about it, is not a really nice way to introduce your child. My little sister was introduced as my parents, this is our little surprise package. What, somebody dropped her on the doorstep? You didn't know what was happening here? Right? Because you called Sam an oops. You did this. This is all on you. And as I have gone through life, the 40 years I have lived, 42 years I've lived, I've heard many people introduce their children as our little accident or various other things.
Like the t-shirts for the kids where I was like, I was intentional, I was an actor.
Yeah, like those, everyone thinks they're real funny, but no.
I'm sorry, Sam.
Whatever. It wasn't a surprise to me. I have 2 children. I know how they showed up.
Oh.
I did that at first too. Because you don't, it's not the closest.
So having to be shirtless.
I did that first too.
That is what you need for the first one, for 2 marks. This is what you need for the second one. For 2 marks. This is what you need for the third one. You don't need to write 40 twice.
Oh, I did.
But some of you, I'm sure, did. And this is what you need for the fourth one.
Wait, so is C still out of 2 marks though?
Yes. Because you still need to recognize that just because theta is also the reference angle doesn't mean it is not still a reference angle. You are Sam McCarr. You are also the kid that sits in that spot. Yes. Also, apparently, the class's accident, according to Am Schumann. All right. So that's out of 8.
Why are you so laughing?
I don't rightly know. Okay is a relative term, Sam.
What does OK stand for?
All correct.
Really?
Yes. In turn of the century in New York City, there was a fashion amongst people that wrote in newspapers and spoke. And one of the fashion was similar to you people saying LMAO and things like that. The fashion back then was to say and spell things poorly because you could, because printing presses and everything made the printed word ubiquitous. So it was fashionable to spell things badly. And all correct was a way they spelt all correct. Okay.
Fascinating.
That's where it comes from.
I'm glad we got this on video so I can look back on this sometime.
I couldn't be happier. One day when I'm the first teacher sent to Mars with Elon Musk to colonize, you can all say, that guy taught me what okay meant.
And so God taught us math in the most important stages of our life, arguably, math-wise, but...
Alrighty. So you have the ratio, you have to find the other three, or the other two, I mean. So to get the full 3 marks available to you here, you must do all of the following. First thing you got to draw it, it's in quadrant 2, so you know it's there. -2/3 means this has to be -2 and this has to be 3. In order to do the other one, you need that angle right, or that line right there, which is of course the square root of 9 minus 4, which is the square root of 5. You get all that, now you are in business. Cos, you already knew. Sine is √5/3. Tan is √5/-2. You needed all that to get the full marks. I think, did you also need to say the angle?
Yes.
I did. You did, didn't you? So any of those things, shift, sine, cos, or tan, will get you the angle. Is theta here? Or is theta here? Green or red? Green. And how big is it? 132 degrees. You needed all of that for the marks. Hello. Please do. No problem. No, it is 3 marks because you needed to do 3 things. So over in this one, I'm going to do this one without the sketch. Okay? Because you can also do it algebraically, yes?
Yeah.
I know the sine. Oh, wait a sec. Let me get my little pen light back. Sine, we know, is y/h. We know h cannot be negative, so it must be -1/3. If it is in quadrant 4, I know that x is positive. Right?
Yeah.
So, my cosine is, I can do tan right now. No. Can't do either. I got to find the hypotenuse first if I'm going algebraically. The hypotenuse, which I know is 3, I need the x equals the square root of the hypotenuse, 3 squared, plus 1?
Oh, minus.
Minus 1 squared, which is the square root of 8. So x is positive 8. So now I know my cos is √8/3, and my tan is -1. -1/√8. And of course, your theta is 341. Making that out of 3, that out of 3, making the whole page out of 14. Any questions? Going once. Yes, Lauren. For just this B one? Would you like to see it drawn out? Would that be better for you? Rather than algebraically? Well, did you draw or did you do algebra? Okay, well, let's draw it out then so you can see. So you know you're in quadrant 4, yes? So you know it has to come down here. Agreed? Okay. And you know sine is opposite over hypotenuse, right? So you know the hypotenuse has to be 3, yes? Okay. Because the hypotenuse is always positive, right? And you know that sine is opposite. So here's your -1, right? So now I need this x value here. So that's Pythagoras, right? So I need this side to be the square root of the hypotenuse squared, 3 squared, minus side A, 1 squared, which is 9 minus 1, which is the square root of 8. Cool? Okay. So now I have all 3 sides. Here's the angle with which I am working. So that's my theta. So then I do adjacent, root 8 over hypotenuse, 3. There's my cos. Right? Cool there? But, so when I got to here, you said that's what you had. Are you good there? Oh, you understand it. Okay. So you understand how this is root 5? Looking at this. Root 8. Sorry, yeah, root 8. It was root 5 over here. You're cool there? And now you just do sine, cos, and tan with these 3 sides. So first, you already had the sine, so you do cos, which is adjacent over hypotenuse. Root 8 over 3 is cos. And then tan, which is opposite, -1 over adjacent, root 8. Okay, and then you use any one of those formulas, shift it to get the degree. You cool? So you did sine of -1/3. So you went to your calculator and you went shift sine -1 divided by 3. And you got -19.5, or -19. Okay, so that means this right here is 19, and it's negative because I went that way. So 360 minus 19. And that's 360 minus 19. Everybody's cool? Okay. Page over. I don't know what one works better for people, algebraically or drawing. So I'm going to do, again, one of each. Okay, if you like to see this stuff drawn, great. If you can do it algebraically, great. Okay, so we'll do this one algebraically. Since it's tan and it's in quadrant 3, I know that x has to be -5, y has to be -3, and my hypotenuse has to be the square root of 25 plus 9, which is the square root of 34. And then, of course, you know that sine is -3 over root 34. Cos is -5 over root 34. You already have tan, and then you shift to get it, and it is 211 degrees.
It's 31 degrees, but then you have to...
Yes, but that's not what the question is. The question wants theta, not the reference angle.
No, actually, sine cos, you got the 2,000.
Sine is y.
Your opposite is... Oh, no, I got it right. Sorry, mine was flipped, and my cos on top.
See how good a teacher I am?
Yeah.
Silence, and he solved his own problem. Know when to let them go. It's a safe space. And I'll draw this one because some people like to see it drawn. Quadrant 3 has to come down here, yes? Since it's cosine, you know the hypotenuse is 8. Has to be positive because hypotenuses are always positive. Since it's cos, this is your -5. So this has to be the square root of 8 squared minus 5 squared, which is the square root of 64 minus 39, root 39. Now, here's where it gets hinky. This has to be what? Negative, because I've dropped down.
Yeah.
So my sine is negative root 39 over 8. And my tan is root 39 over 5. Positive, because they are both negatives, and two negatives give me a positive. Smart. Nice. And of course, the angle is 231.
Yeah.
3 marks for each of those. 3, 1, 2, 3. Thank you, Rosemary. One person got it. I said 3, and then I said 3. Because 1, 2, 3, 4, 5. I can't count past 5 in German, except to know that, no, I can't count past 5 in German. 9 isn't 9. 9 is no. The number 9 is 9. 9, like noise, but 9. Yes. 1, 2, 3, 4, 5, 9. Thank you, Lauren. Do you know more German? No. You only know the number 9? Of course. Oh, interesting. Good to know. See, everybody's learning stuff today. Number 3, draw the angle in standard position. Why are there 2 values?
There's 2 possibilities. Sine can be positive.
Because sine can be positive in 2 spots.
Yes.
So you will get 1 mark for this. Whoop, 13, 5. Whoop, 13, 5. That will get you 1 mark. Okay? Now I need the values of cos theta. To do cos, what do I need? I need the third side, yes?
Yeah, need x.
So that is the root of what? 13 squared minus 5 squared, which is 169, minus 5, which is minus 25, which is 144, which is 12. So the values of cos theta are 13, 12 over 13, and negative 12 over 13. And that gets you 1 mark. Why is only 1 mark, Mr. Myers? We had to do Pythagoras. Yes, you're in pre-diploma grade 10. Pythagoras should be like that. And find the values. Of course, you just shift sine or shift cos or shift tan, any of those, and find the values are 23 and 157. For 1 mark. Making that whole question out of 1, 2, 3. Wait. Out of sun. It's Japanese. Evelyn, come on, I need Thai. Fine.
Yunji's gonna get mad because you're saying it wrong. I know, Yunji's like, oh my god, it's not right. It's like,
You know what always bothers me?
What?
When you meet somebody who speaks another language.
Yes.
And they say to you, you ask them, hey, how do you say blah, 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 blah? And they say, well, it's Snicklefritz. And you say, Snicklefritz? And they say, ha ha ha, you're an idiot. You know that? You know that thing? But if you did that back to them, because we are English speakers, everyone would be like, oh my God, they're ELL. How could you do that?
Oh my God.
the language rules are the same as the race rules.
It was on the ground. I didn't steal the money.
I, of course, always say to a person, you speak infinitely better English than I speak Spanish, Thai, Filipino, Japanese, whatever. Huh? That's one of the languages spoken there.
Yeah.
Yes.
Chinese a language?
No, Mandarin is a language, and Cantonese is a language, and Fukiin is a language, and ironically, they all share the same writing, but they are spoken differently.
But my friend that's from China is like, no, what are you talking about? Chinese is a language.
Wait, but like,
Only a very, very small portion of China's population speaks anything but Mandarin. It's kind of like French in Canada. Right? Yes, Quebec is the biggest province, but population-wise, less than 30% of our population speaks French.
I think that's more southern China that speaks
Cantonese is the corner where Hong Kong is, the Canton province, Cantonese. No, it's not from Pokemon.
What did you say? From what region? California.
How do you know that, by the way?
I love Pokemon. Pokemon is the best.
There was a Pokemon called my family.
I used to trade Pokemon cards before they banned them from my school because they got
Pokemon Go!
Wait, like, have you got anything
Yo, I haven't got it. Tired as heck.
I went.
That's fine.
traded Bella's
Dagger snake.
I traded a shiny Bella's Sarah card for a normal one.
Did you get everything? No,
The shiny one.
Why?
what is
Give yourself a mark out of 25. When will you report that mark to me? Monday on your quiz.
Why don't we just do it now?
Because some people do not like to report their numbers out loud, and I am too lazy to walk around. That's why.
Can we just come up to you?
No!
Can I come up
No!
to mine so I don't forget?
La 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 la. What? I want to hear you, Lauren.
Bye, Blake.
Bye, Blake.
Where are you
Good luck.
going? Football. He's leaving. Bye, Blake.
It's okay, like, everybody I love leaves me. Everyone I love.
Yeah. What?
Wait, that was
He's gonna get it.
Yeah, righty then. The class opened up their books to page 81, and then they promptly put down their pens and pencils so they could watch something on the screen.
Is this one of those questions?
Now.
Oh, I get what you're doing, Kayla.
Thank you, Kayla. You're welcome.
Are we gonna learn about why these cosine and everything works? Because this is law. Well, are we gonna learn why they work and what the numbers are and why that's what we do?
No.
Well, no, because they're just you punch them in, not even thinking. I just like okay, never mind. Apparently, I'm.
No, you're not,
I'm
Taylor.
trying to figure out.
You want to understand why they work, but I showed you why they work.
Well, no, I understand. Never mind.
She's just asking like why the number for sine is that number.
Well, yeah.
Like why that decimal comes up?
Yes.
Okay, but again, you've seen that on the very first page of your notes.
Well, never mind. It's okay.
No. I like questions like this, but this is why. Remember this drawing?
No.
We never did that.
Oh, you did it last year, that's why.
Oh.
So, to remind you then, if I should do that actually, fair enough. Let's take a moment and show why trig works.
Okay. Thank you.
How long is that? Excellent. How long is that? 3. Right?
Yes.
Okay. How long is... Pretend this is going right here. Actually, you don't need to pretend. I'll draw it right above it.
Well, I can't see.
It'll show up. You know as well as I do, this we are shackled with garbage.
Oh.
That green one,
Yeah.
how long is that green one?
12.
12. And how long is this green one? 9.
9.
9!
Oh, okay.
And finally,
20.
the pink one, which should be down here, right? Up to here is 20 and 15. Yes? Everybody cool?
Yeah.
Okay, now, what did I just draw? Sine, cos, or tan? Tan. Opposite over adjacent, yes?
Yes.
Okay, so now if I make this triangle with red, what's the hypotenuse?
5.
5. If I make the triangle with green, what's the hypotenuse? 15. If I make the triangle with pink, what's the hypotenuse? 400 minus 225? 175, square root of 175, yeah?
25. What? No. Someone just said 25.
Or sorry, it's adding 625, so that's 25, right? I did subtraction there like a dummy head. Okay, so you're all cool with that, yes?
Yeah.
Like that makes perfect sense to everyone, right?
Yes.
Okay, so you have 3 different triangles that all have different angles, yes? Or different sides, yes? Do they have the same angles?
Yes.
Of course they do, because this angle right here is shared with all of them, isn't it?
Yes.
Okay, so that particular angle, anytime you draw a triangle with that angle, and you compare these two distances, you are always going to get 0.75.
All right.
Okay? So that's your tan will always be 0.75. Your sine will always be 0.6. Your cos will always be 0.8.
Okay.
No matter how big you draw a triangle, if you draw it with that angle, that's what the ratio is going to be. And this ratio happens to work out to 37 degrees. It's actually 36.86.
Oh, okay.
So what that means is if you ever draw an angle of 36.86 and you make it a triangle, these ratios will stand. Every time you change that angle, these ratios will change slightly.
Okay.
That's why trig works.
Okay.
Now back in the day, there were no triangles. So somebody sat down with a calculator, not a calculator, with pen and paper, and worked out all the decimals for all the angles from 0 to 90, because you don't need to go past 90.
That's a lot.
So when your grandparents did trig, when they were in grade 10, they had a sheet of paper that looked like this. Tan 1, sine 1, cos 1, and there would be a decimal. Blah, 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 blah. Then it went sine 2,
No
cos
way.
2, tan 2, 3 decimals, blah, 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 blah. And then when they did work, for example, it was the sine of 74 equaled opposite over hypotenuse. Sine 74, they didn't go to their calculator, sine 74. They went to this list, found sine 74, got the decimal for it, blah, 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 and wrote it there. Blah, 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 equals O over 17. Then they had to do 17 times blah, 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 to get the answer.
Gotcha.
No calculators. The thing they actually use to work all this out is called a slide rule, but nobody uses those anymore. They're kind of like math museum pieces. Now, yeah, like they slide, all three things slide independently of each other. And they basically do calculations. So that's why trig works.
Okay, thank you for reminding me.
Sorry, guys. Let's get back to business.
Sorry, I stopped. Intellectual question. Sorry, that's my deep intellectual question for the day.
Excellent. Oh no, we're working on this. So as I was saying, I'm gonna get you to tell me that's 17 and I would like for you to tell me the other two distances. Can you do it?
Yes, we can.
How? What would you do? Talk to each other. Don't write anything down. Talk. How are you going to do that? Don't write this down. What are you going to do with that right now? Go.
Okay. Oh yeah, there's no right angles. That's a 98.
Sure. Everybody has this in their head, right?
Yeah.
I can turn off the screen for a minute because people keep looking up at it. I want you to think.
Oh, okay.
I'll leave it up there. Never mind. Carry on.
We're just trying to figure out how to get X and Y. But everything we've already done. This is just proper time. Like it's not 93.
This guy is so
Okay, well, then.
He probably is.
Okay, so A, what's angle A? Or no, you just have to switch them up. So let's see. What's the larger?
Yeah, the one with
What would be the longest side? Those are all the angles. You'd have to figure out
So x divided by 7 is equal to 7.
Wait, actually, no.
It might be because sine A is the angle, right? And then A would be the opposite of it. I think.
Do we have some ideas yet?
Well, yeah, because the opposite of X is 7.
Any fun? Any fun? No fun? Who got a job? Good job, Kayla.
Where are you?
Now you can join the rest of us.
Oh, and then if I do this times 37, X should be 14. X should be 14.
Why?
Because 7 divided by 45 would be 7. So sine, and then y,
Let me see that.
1 to 4.
Oh yeah, I gotta go.
Oh, okay, so if it's 14 divided by 37.
Make copies.
Those two are.
Okay, so if we do that 98 times 0.38, y is
Should be 39.
or you
What do you remember what we did?
Wait,
I can try to, I can just a second.
It's not fast track.
Well, and then just plug in like, so I'm taking.
Since the angle to the opposite leg should be the angle to the other.
You guys ready yet?
So 17 divided by
All right, let's hear some ideas.
0.3. And then if you do 37.
0.38.
So x is 14.
All right, who has an idea for me?
14. Sam and I do.
Samuel.
Okay.
I know that's not your name, Samuel.
I know. But
Explain exactly what you're talking about.
so I was looking at the sine law page, and
So cheating.
yeah, but like
Carry on.
It didn't really say anything, but I just saw the formula
Mm-hmm.
because I didn't know how to do it.
But then we applied knowledge and thought about it.
That's even better.
Yeah. So I thought that since they're like the sides and the angles are like equal to the other sides and the angles, wouldn't it be that when we did 17 divided by 45 equals 0.38, and then 37 times 0.38 gives you the answer to x, which is 14, and then 98 times 98 times 0.38 gives you the answer to y, which is 37.2.
So
Is that
you,
right?
37.24, and you say this is
14.
X was, yeah,
exactly?
well, it was 14.06.
Okay. All right, so that's what Sam did, and Taylor, which is fine. They applied knowledge. They took a guess. I'm not going to say if it's right or not because we're going to go over it. Did anybody have another idea? Blake. So Blake says, just let me use a different color that is quite obviously different from blue. Blake says go, and then what?
And then you sine and cos to get the bottom and the height of the new line you created.
So Blake says sine and cos will get our height, and it will get this part, because this triangle has two pieces of information, yes? Okay. And once I have this and this, do I then have two pieces of information for over here? Yes, and that's what I would do. Absolutely correct. Good job. Now, a great many people smarter than you and me recognized this and saw, rather than do sine, cosine twice, they developed the sine law. And here is what they did. They did exactly what Blake did, and they said, all right, so this right here, we're going to call it H for height, not hypotenuse. Everybody cool with that? And they said to themselves, if I can find this, then I can use that to work over here. So this side here was the sine of 37 equaled the height over 17, correct? Everybody with me? Everyone agrees? How would you solve that? Height equals 17 sine 37. Everyone agrees? Okay. Now, come over to this side, over here. Right? Everybody with me? Height over here equals, no, I don't want to do height, sorry. So, I'll change colors too. Does yellow show up? Not bad. Sine 45 equaled what?
Offsetted by 35.
Yep. So it was h over x, yeah?
Yes.
Everybody cool with that?
Yes.
But we know what h is, don't we? What's h?
17 sine.
H is 17 sine 37, yeah?
Yeah.
So, what does that tell us? That tells us that the sine of 45 equals 17 sine 37 over x, yes? How do you solve that? 17 sine 37 over sine 45 will give me x, yes? Everybody with me? Everyone's good, right? Okay. Doing that, they also recognized that since h is in there and h is in there, they must, and Sam knows this because he looked ahead at the piece of paper, they must be related, yes? And through experimentation, they came up with, now we're going to open our books to where we were here, A over sine A equals B over sine B equals C over sine C. All those are our fractions, right? And you already know about fractions. What do we know about fractions? That they are ratios. And we know ratios and triangles do what for us? What?
Find the angles in this.
Find the angles in the sides. So, we are going to draw any triangle. Please do not make it right-angled. So we've drawn our triangle, yes? Label it. Where does the capitals go? On the corners. A, B, C, on the vortexes. I know, I wish he was here. And where did the small letters go?
A goes to the
Little a,
opposite.
little c, and little b.
Probably in that honors PE thing.
She is.
Yeah, she got yours now.
She has. So, knowing what you know now, right?
Yeah.
Knowing that there's an H, right?
Yeah.
We know that sine A equals X. Come on. Just wait a sec. Sine A equals what? H over C, yes?
Oh, yeah. Sine.
Yes? H over C, yes?
Yes.
Right? So H what does H equal?
Got it. C
C
times times.
sine A, correct?
Yes. I guess right.
Like small
Yes.
Oh, I thought it was a big.
No, small c. Right?
Wait, that's
Yes.
the sin C.
No,
The small.
small c.
Oh, yes.
C?
That's
Why?
Because the sine of A is H
Oh, okay, yeah.
over C.
Yeah, okay.
Everybody good?
That is a-
Okay, now, what then is sine big C? H
Over.
little a, yes?
Yes.
Which means H also equals what?
A sin C.
C.
C. That's what I meant.
Sine C times A.
Right, equals
Because
Is it frozen or is it?
Oh, it's frozen, yeah. Thank goodness I have such good technology to teach you guys your math. Sine C. Yes?
Yes.
Now, you guys are smart kids. If h equals that and h equals that, what does that tell us about that and that? That they are equal. So C sine A must equal A sine C, correct? Does everybody follow that logic? Now, math guys are like you and me. They like things to be pretty. They don't like this C living with an A, and they don't like this A living with a C. It's like the show Three's Company, how Mr. Roper didn't want Jack living with two girls. None of you have watched that show. It's on Netflix. Do yourself a favor.
What's it called?
Never mind. Three's Company. Now, what would I do to get rid of this A? So A wasn't living with C. I would divide by A, wouldn't I? What would I do to get rid of this C? Divide by C. If I do the same thing to both sides, where does this A go? Over here. I got to divide by A, don't I?
Yeah.
And then this C would cancel here and go over here, yes? Now, you guys are smart kids. If sine of big A over little a equals sine of big C over little c, there's how many sides to a triangle? 3. So if 2 of them work, does the third have a choice? So it has to be sine B over little b. Sine big B over little b. Now, please notice that proving the sine law, the way we liked to write it out, gave us the sides on the bottom, right?
Yeah.
When most people write the sine law, they like to write the sides on the top. Why did I prove it to you this way, but give it to you written this way? Why would I do something that seems at first glance so confusing? Sam? Okay. I like doing it that way simply because we've just finished our SOHCAHTOA unit, right? And if we had numbers in here, this is the way we would do it, yes? Previously to when people cared that you guys knew why things worked, your math teacher would have said, here's the sine law, use it. That's what my math teacher said to me. Here's the sine law, use it. That was the extent of his instruction to us. His extent of instruction in SOHCAHTOA to us was, SOHCAHTOA, use it. Yes, sir. Okay, Mr. Stewart.
You called him sir?
Yes, sir.
Would you be mad at
I call all my teachers sir.
You do?
I did. Because I was too lazy.
Oh.
Mr. Stewart, sir.
Do you want us to call you sir?
No, I couldn't care less.
Can I call you sir
You
then?
can call me whatever you want. Just don't call me late for dinner.
Okay, whenever you want.
Get it? Huh?
Call me late for dinner.
Because I don't come late for dinner because I'm fat. Because I always gets to dinner on time. So don't call me late for dinner because I'm never late for dinner.
Because you like eating. Okay.
Because I likes to eat.
So we just called you out by your last name, like if you were just Myers. That would be
I don't care, but that actually really bothers some of the teachers in this building.
I've noticed.
It really bugs some of the teachers. Because it's taking away the term of respect that the Mr. or the Mrs. gives.
But we respect you very much.
I am aware of that because it is not my hang-up.
Okay.
It is their hang-up,
Okay.
right?
I was just wondering.
They have a hang-up about whether or not they are Mr. or Ms. Some of them have a hang-up if they're Mr., Miss, or Mrs. Some of them have a hang-up, eventually, with the people, with the way society is going, eventually somebody is going to have a hang up with any honorific. They will have to come up with new names. Zister, Zissus, and Ziz, I guess. Because saying Mr. Myers, that has a gender assigned to it. Now, at any rate, the real reason I showed this to you is, one, all of you could follow the proof very easily, yes? Because it's the way you would have done it. But I like to show this proof but write it this way simply because it doesn't matter. Right? If I flip over all of them, I'm going to get the same values because I'm going to be doing the same multiplying and dividing wherever I need to. Okay? Lauren.
So wouldn't that then mean that sine A equals little a?
Where?
Because if you're representing it by a over sine C.
This one right here. Yeah.
And then your other one is sine A over little a. Then if you're treating it like division, that would mean that sine A equals little a.
But this is indeed divided.
But then it would, since you represented it at the top, little a over sine A, would it be a divided by sine big A?
That's what this is. This is the side length little a right there divided by this ratio. Down here. Down here, it would be the ratio, the decimal, divided by the side. No, of course not.
Then why are you saying that they're the same thing?
Because it's not this that's the same thing. It's, oh crap. It's this whole operation equaling this whole operation equaling this whole operation. If I do this, I'm going to get some number, yes? And if I do that with all three of them, with the side on the top dividing by the sine, I am going to get the same number. If I do that down here, I am going to keep that equality, but this is not going to equal that. Okay? It's like saying 5 over 2 equals 10 over 4 equals 15 over 6, right? Yeah. They are all equal. Switch them around. 2 over 5, right? 5 over 2 flipped. 6 over 10, or 4 over 10, right? You would just keep the same. Cool? Okay, so now let's apply what we know. I have a triangle. Does it matter how I draw the triangle? No, so let's draw it. Boom, boom, boom. That's a horrible triangle. Whew. I'm embarrassed by that triangle. And of course it's frozen, so I can't erase how ugly it is. I'll just take a moment here. There we go. Let's make a triangle. Excellent. Oh, thank you, Sam. And let us please draw in the angles. Now we have to use, we don't need to do this, but it often helps. I'm going to choose just randomly that this is A, this is B, and this is C. What do I know about my triangle? AB is 6. Lovely. What else do I know?
A is 40.
A is 40. Lovely.
B is 75.
Come on. B is 75. And that is all I know, yes?
Yeah.
Is it all I know?
No,
I know my third angle. Why?
180.
Angles and triangles have to add to 180. So what do I get here?
whatever 75 and 40 is, subtracted by 180.
65 degrees. Everybody cool?
Yeah.
Now, what do I have? I have big C,
Oh, little c.
big B,
and
big
big A,
little
and
a.
little c,
Yes.
don't I?
Ooh, ooh.
So, I have the sine
Oh, yeah.
of big C, which is 65, should divide by what? Little c, which is 6. Yes?
Yes.
And I know that that has to equal the sine of A divided by what? Oops, not A, because we know A.
40.
40 divided by what? Little a. And I know that the sine of 75 must divide by little b. How do I solve one of those algebraically? Can I solve this one?
Yes.
Okay. Can I solve Can I solve how to get a piece of technology that works once in a while? Can I solve that purple one right now?
No.
Why
You
not?
have two unknowns.
Two unknowns. So the first one I got to work on is the green one. How do I solve that?
Cross multiplication.
We call it cross multiplication. That's not what it's really called, but we're going to leave it like that because that's what everybody knows.
What's it really called?
What? Never mind.
Okay.
We'll come back to that because everybody calls this cross multiplication. So what do we do?
Cross multiplication.
Okay. If it was cross multiplication, then we would multiply, wouldn't we? And what we would get was A sine 65 equals 6 sine 40, which doesn't tell us anything, does it? All we've done is cross multiply.
And then now you divide.
Okay, so really it's not cross multiplication, is it? Right?
Cross multiply divide.
Cross math.
It is neither just multiplying nor is it just dividing. So we cannot call it cross multiplying, cross divide. What it is proportional.
Multi divide.
It is proportional reasoning, isn't it,
I
Leighton?
didn't know.
Right?
Proportion.
It is proportional reasoning. So we know that 6 sine 40 divided by sine 65 must give me A.
Yes.
And if I do that, I get a number on my calculator, yes?
Yes.
So make it so.
The word.
It's 4 point.
Okay.
4.5.
Now, stop. It's not 4.25, is it, Sam?
No.
It's 4.25, blah, 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 blah. Yes?
Yes.
What do we write on our paper? Fine, 4.25. If it indeed rounds to 4.25, I haven't checked.
Yeah, it's 4.255.
Now, great. So it rounds to... Okay, fight later. Not the point. The point is, I'm going to need this number over here, aren't I?
Yes.
It's on my calculator, isn't it?
Yes. Or you can just use that.
So, now, do you remember why in the last SOHCAHTOA unit I had you not go to your calculators?
Yes.
Yes.
Right? Because as we get to more and more complicated stuff, doing it all at once would be very helpful, yes?
Yeah.
So I know that that's my A. It's already sitting on my calculator. Now, if I come over to here and I do this one, I know that this is A sine 75 divided by sine 40. So A is already sitting on your calculator, yes?
Yes.
So you will push
6.
times
Yes.
what?
Sine.
Oh,
Sine 75 divided by what?
Divide by sine.
And get
6.394687368.
6.4.
394. What?
6.4.
6.394687368.
So 6.4. Right, because the 5 will round up. Everybody cool?
Yeah.
Is everybody good? Now I want to do a little bit of talking here. If B is 6.4, where does that go on the triangle we drew? The bottom. Excellent. 6.4. Where does 4.26 go? Now, I want you guys, let's call it 4.3 to keep the one decimal thing going. I want you guys to look at that red triangle there and come up with some things that you are noticing. What do I mean by that? There's no wrong answer. There is some stuff in that red triangle that you should notice. Talk to your neighbor and see if you can come up with something about that triangle that relates angles to sides. And it can't be the sine law, because I've already shown you that.
Mr. Mark, can I please go to the bathroom?
Yes, please do.
Bye, Taylor. Good luck.
Why do you guys do this every time? I'll be back.
Go full in.
Make good choices.
Is it the cosine law?
Huh?
The cosine law?
No, it's not the cosine law.
Tan law.
You will never figure out the cosine law. The cosine law is crazy.
You never
Don't be dumb. Okay, I'll help you out. What do you notice about that angle compared to the other two angles? It's bigger. What do you notice about his partner compared to the other two sides?
It's greater.
It's the biggest. What do you notice about the little angle?
It has a small side.
It's got the smallest side. What do you know about the middle-sized angle?
It has the middle side.
It's got the middle-sized side. So, can you always check if you have done your sine law incorrectly? Yes. And that kind of makes some sense, doesn't it?
Yeah.
Because if we think back to our good friend Sokotoa, middle of the night, I know. If we think back to our good friend Sokotoa with a right angle triangle, how big is this angle? 90. How big is this side? Doesn't matter, but it's the hypotenuse, which means it is what?
The biggest.
The biggest side.
Oh.
Oh! Which of these angles, I should have drawn this better. Which of these sides is shorter? This one down here, right? Which is going to be across from this angle up here, right? Which has to be the smaller of these two. Yeah, Taylor's going to be sad she missed out. That was prime time right there.
Wait, what happened? Oh my God, go back.
Oh, you were imitating Taylor. You were the last person. There's a saying, Sam, people who live in glass houses should not throw stones.
Why?
Because it's made of glass.
Wow, you're so smart.
I don't get it.
If you live in a glass house and you throw a rock,
It's a break.
it will break your house.
Presumably, your house
So-
would be made of this glass that wasn't like paper thin.
That means if you live in said glass house, you shouldn't throw a rock because it will break your house, which means other people should not throw rocks either. The saying applies to Taylor being out of the room, you reacting the way oh my God, go back! When you aren't here, and that's how you would
I know,
react.
that's what I said. I did that too.
I know, that's what the saying is. That's what it means. People in glass houses shouldn't throw stones. All right. Now, oops, I have traveled too far in my note writing. I will show you. Oh, fudge off. Oh, maybe it'll work. No, of course not. Look at the next one and see if you can figure out how to draw it.
So there are blank spaces on the sheet.
That's why I shrunk my notes, because I want to write something there. But I'd filled that in. Solve where? Oh, crap. Thank you. Right angle triangles. Whew. All right. Solve the triangle. What does solving the triangle mean?
Find all the angles in this.
Right. Means find all angles and sides. Now, let's draw it. How do I start?
Make a triangle.
Make a triangle. Sim, sim, salabim.
Label D.
Label D, E, F. Does it matter how I label it?
No.
No. Where do you want to put D?
D.
I don't want to assume your D identification. Bottom left.
Bottom left corner.
Excellent. Now, what does that mean? What else can I write in right now?
Oh,
Little
the
D.
other opposite
Oh, yeah.
side is 7 centimeters.
So that's 7 because that has to be lil d, doesn't it?
Yes.
Okay, now, what else do I know?
You know that
Top
E.
is E.
You want to make this one E?
No.
No.
Like the big E.
You can't put big E.
No, but like guys in general, like the letters.
Oh, you want to make this big E.
Yeah.
Okay, so that makes that F.
And then.
So what goes here?
12.
12, because that equals little e. And what else do I know?
That.
No.
Anything else?
No.
Nothing.
No.
That's it.
I'm stuck, aren't I?
Yes.
Okay, so now, hey, wait a minute, Mr. Myers. This is D, E, and F, and sine law is A, B, and C. Don't laugh, Gurpinder. Kids get mad at me for this. Yes. Yes.
But what
So,
if it's a shape with
does it matter? Can I say sine of lightning bolt over lightning bolt is the same as sine of Pac-Man over Pac-Man?
Yes.
Is the same as sine of fish over fish? Yes. The letters don't matter. So, what do I know? I know that the sine of 35 compares to what? Oh, wait a minute. Let's change the order just to prove. 7 over sine 35 has to equal what?
Sine 12 over.
Sine big E, right?
Yes.
Okay. Can I figure that out? Why? Because it's proportional reasoning, yes?
Yes.
What would I actually do there?
12 times sine.
12 sine 35 divided by 7 gets me sine E, doesn't it?
Yes.
Okay. Do I want sine E? I want E, don't I? So what am I going to have to do once I know sine?
Divide by sine.
Divide by E.
No, divide by sine. Divide by sine. Right?
I didn't know what I'm saying.
I'm getting a sine. Do I want sine E or do I want E?
You want
Sine.
I want E. So what gets me from sine E to E?
Divide by sine.
That's what I said too.
subtract sine. No,
mean-
right?
Wait, what do you mean?
Pardon me, Jasmine? Shift sign, thank you.
Oh, it's
Whoa, sorry.
Now, let's stop for a moment.
We were thinking algebra.
Let's stop for a moment. If I punch this into my calculator, I'm going to get a yucky decimal, yes? And then I would need to shift sign that decimal. Can I streamline this process using brackets in my calculator? How? What would I do before I did any of this?
Bracket.
I would put shift sign right there. And that would give me the right answer. If you can't do that with your calculator, just do it in 2 steps. Does it matter? No. Everybody cool? So what's E? While my computer freezes, I'll let you all punch in what E is.
I think it's 79.5.
80.
Yes. So E is 80 degrees. Do I now know F?
Yeah.
Yeah.
What is it?
Um.
65. Now, I know that little f over what?
Over sine.
Sine 65 will work. Yes?
Yeah.
So what am I going to use? Could I use this if I wanted to?
Yeah.
But if I didn't write it down, I can't, can I? Because if I just did this, I don't actually know sine E. I've only found E, right? So what could I do? I could go back to this. Since they're all equal. That's the point I'm trying to make. You don't have to go A, B, C. You can go A to C, B to C, C to A, B to A. Lauren.
The last question I in question one, I did that, and I got a different number.
Then you either punch something into your calculator wrong, or you wrote something out wrong. Because you can't possibly get a different number if you do the calculation right. Right? Because if we actually got out rulers and stuff, you'd believe me. Like, right? Yeah. That's the only thing that happened. Right? You know what you're doing. You just hit a button wrong or miss out a bracket. Something stupid and little like that. Because I know you know how to do trig. Right? I know you know how to do trig. Yeah, you do. All right. So is everyone cool?
Yes.
So we can now find angles and sides. Yes? And we know that the biggest angles cross from the biggest side, littlest angles cross from the littlest side, middle angles cross from the middle side. Yeah? Everybody gets that?
Wait, Mr. Myers.
What?
Oh my gosh, there's a cosine law. Holy.
Yeah, you thought sine law was...
Is that tan law?
No, there is no tan law. There is a cos law. And cos law is like...
It's like a mix of vegetables.
It's bad news. The cos law is the plate of Brussels sprouts on the Thanksgiving table.
Is coleslaw like the reason that on...
No, that's whole slaw.
Is that because we have a poem called sine, cos, and tan?
You have a what?
A poem.
A poem for sine, cos, and tan? Oh my goodness, is it in Vietnamese?
Yeah.
Say it.
Xin đi học cốt không vì you don't understand, right?
I know that. That's still cool. So
I
go. It's your version of Sokotoa, right?
Yeah, but
We have Sokotoa. You have a Vietnamese poem.
xin đi học cốt không hư tan đoàn kết cốt tan kết đoàn. That's the poem. I can remember that.
Mr. Myers, on a scale of 1 to the reason that there is important message, this is a difficult course on the first page of our Gamma Green book, what is coleslaw?
Coleslaw is... What?
He's answered my question.
On a scale of 1 to...
This is a difficult
Oh,
course.
okay. Coleslaw would come in around... This is a difficult course. About halfway between this is... Between is and a.
So it's not the hardest?
No.
But it's really hard.
No. Actually, you guys, coleslaw is actually very, very easy to use. It's just ugly. Because when you turn the page and see what it looks like...
Very easy to use, just ugly.
Yeah.
Mr. Myers.
Okay. We're stopping. We're stopping.
We have 7 minutes.
Yes,
I
we're
think
stopping.
Our computer stops.
Of course my computer stopped, because it's a piece of garbage.
Since we finished, can we do a word problem? Like as a reward for getting
Every
through
day.
that?
That can you work home? I'm here that
Yeah.
Now, listen please. Listen please. Listen please. Listen please. Listen please. Listen please. Listen please.
Guys.
Listen please. Okay. You have a quiz on Monday on everything to do with proportional or coordinate grid trigonometry. So, cast, theta, reference angle, right?
Standard
Okay.
position.
Standard position,
Terminal arm. All those
terminal arm, all that stuff. That is all on Monday. So I'm not giving you any homework on sine law because I want you preparing for that. Okay? Now, like I said, sine law, pretty easy. We were able to prove it. Everything worked nicely. Cosine law is just ugly, but it's actually just as easy to use. Okay? It just, you use it in a different situation. Okay? Everyone is Gouda?